Hey guys, so today we're going to go over how to graph a polynomial with the use of the function itself, the derivative of the function, and then the second derivative of the function. You guys have already seen how to use functions, how to get from functions to derivatives, and now I want to show you how can that be used to help you graph functions, right? So let's say we had a function, let's call it f of x equals x squared plus, right, and we want to graph it. And what I basically want to show you is, as we graph this thing, how each piece of these information can help us graph, right? So let's start with this one. I have the function itself, and I want to help it to help me graph the function. So I'm looking at this function. The first thing I can do is set this equal to 0 or find the zeros, right? So find the zeros. So I would do this by setting the function equal to 0, right? You're going to see that this, later in a later lesson, there's something we can do called factoring, but I won't show you how to do that right now. It's called factoring, and we'll talk about it in the future. But I can rewrite this with factoring to look like x plus 6 times x minus 2. Like, these are actually the same thing. And now with this, if I were to set this thing equal to 0, I would be able to say, oh, if x equals negative 6, that would be true, and if x equals 2, that would also be true. So my two zeros are negative 6 and 2. So I already know those are going to be important at some point, right? So I know that, okay, if my function is equal to 0, right, so I set this equal to 0, that actually means y equals 0. So this whole process is telling me these are the x's such that y equals 0. So I can be like, oh, okay, I already know that these are points. I know nothing else, but I know that these are points. Now let's see what happens if I take the derivative, and let's see where that can help me. So if I took the derivative, I would get this. From here, you do this thing, basically what we're going to do is the exact same process. When you set the derivative equal to 0, or the derivative of the function equal to 0, these are called critical points. Find the critical points, right? So this is the derivative now is equal to 0, right? So, or y prime is equal to 0. So if I were to do that, I were to say, hey, this is equal to 0. When does that happen? That happens when x is equal to negative 2, right? So if I were to plug in negative 2 for x, I would get negative 4 plus 4 equals 0. Great. So this is called a critical point. If I had more of them, they'd be critical points. And again, that's when the prime is equal to 0. So how would this help us? If we think about it, one key point to think of is when the derivative is equal to 0, this thing is a max or a min. A local max or min, right? So it means the thing, if you think about it, if the derivative is equal to the slope, and the slope of a function is 0, that would happen right here. So it's either a max or it's a min. So the way we're going to use to figure out which one of this is, there's a bunch of ways to do it, but the way we're going to figure it out is, let's plot this on a number line real quick. All right, so I have negative 2. And up here is the second derivative. So at negative 2, we know it equals 0. I'm going to pick numbers to the left and the right, and I need to figure out whether these are positive or negative, and I'll show you why in a bit. So if I plug in 0 into this function, I'm going to get 4, right? And 4 is positive. So I'm like, okay, for all values greater than negative 2, this is positive. If I were to plug in 10, I would get also a positive number, right? Something went wrong here. Oh, yeah, sorry, there should be negative 10. So if I plug in negative 10, you'll see this is negative 20 plus 4, so it'd be a negative number, right? So what does this mean? What is a slope of positive to negative? What that means, if you see something like that goes from negative to positive, it means the function it's decreasing and then it's increasing, right? If you see something go from positive to negative, it's increasing, then it's decreasing. So to put it more specifically, the derivative is positive, the function is increasing. if the derivative is negative, the function is decreasing. What does this mean? So let's think how we can use it. At negative 2, I know the function is, okay, so it goes from negative to positive, so I know the function is going, it's decreasing and then it's increasing. If something is going like this, it couldn't really be doing that like that, right? It would have to be doing it like this. So I'm like, alright, great. Looks like, oh, that's a terrible way to draw it, but looks like this. Great. So now let's do two things. Let's find the min of this. How do we do that? So again, we know the derivative here is equal to 0, because as I said before, if something is equal to 0, it's a max or a min, so you know that's the min there. The value itself, if I were to just plug negative 2 back into, where's the function? This function, it would be 4 minus 8 minus 12, so 4 minus 20, which is negative 16. So this point would be negative 2, negative 16. But lastly, let's quickly talk about, and again, I know this is going to go over the time period, but if I took the derivative of this guy again, I would see it's equal to 2. So you know, when the second derivative is equal to 0, these are called points of inflection. And basically, if you find that, which means that's when like the derivative changes, so just so you're aware, if you have a second derivative where it's always positive, it is going to be, oh, you know what, you can't see this anymore. So let's actually, let me push it up a little bit. If you have a second derivative where it's positive, you're going to have something that's called this, and that's called concave up. If you have a second derivative that is negative, you're going to have something that looks like this, and it's called concave down. So again, I'm going to quickly go over this. I know this went over our limit. We're going to break into sort of each of these components in another lesson. I just wanted to make a quick kind of thorough overview. So I'm trying to graph a polynomial with just the base function itself. I can find out these points where the point is, where the function is 0. With the derivative, if I set the derivative equal to 0, I can find this thing called a critical point, and that is when the slope is equal to 0, so it's either a max or a min. And we found here it's negative, there it's 0. We didn't know, like, we know it's a max or a min, but how do we find out how? We use this quick exercise. So we plugged in the critical point. We said, hey, let's look at a number that's less than that. It's negative, so that means that it's decreasing. We looked at a number to the right of this that's positive, so we said we know the function's increasing. So if you're going from decreasing to increasing, you have to look like this. Another way to confirm that is if you go to this point, you say, hey, this is a positive, and as I just told you, if something is, if the second derivative is positive, it's concave up. So this is another sort of, you know, it basically confirms what this had already said. So again, we're going to break this down in another lesson, but this is a very quick, very thorough, very dense overview.